Hello students, today we are going to learn about the previous year questions related to JEE Mains because the JEE Mains examination is very near to you. So I hope it helps you a lot. Okay, let us discuss the problem. See, two identical metal spheres A and B, when placed at a certain distance in air, repel each other with a force F. Two identical metal spheres. This is one identical sphere A and this is another identical sphere B, and these two spheres placed at a certain distance in air. Let us suppose the distance between the two spheres is R, and the two spheres, the force acting between the two spheres is given, which is equal to F. So F is the force acting between the two spheres, and these two spheres having the same charge, because these two are identical, and having charge q, let us suppose, and the force acting between the two spheres F is equal to k into q square by r square according to Coulomb's law, right? See the next point. Another identical uncharged sphere C is first placed in contact with A and then contact with B, and finally placed at midpoint between the spheres A and B. Find the force experienced by the sphere C will be. Actually, we bring another identical uncharged spheres because these two are the charged spheres having charge q. If you place any other sphere which having the identical sphere, which is identical sphere but having these two spheres having charge q, and this is uncharged sphere which is placed in between A and B. Before going to place C, the sphere C is first placed in contact with A and then contact with B. So initially it is in contact with A. So before the charged sphere C is placed at this point, it is initially in contact with A. Then what happened? If any uncharged sphere is contact with the charged sphere, then average charge is located in between the two spheres. We know it. So C having the charge 0 and A having the charge q. So what is the initial charge on the C? Q by 2 while contact with A. Okay. So C contact with A, the charge on the C is Q by 2, and of course on the A is also Q by 2. And next, if the charge contact with B immediately, then what happened? It having charge Q by 2. Initially it is uncharged, but when it is contact with A, it having the charge Q by 2, and later the C is contact with B, then total charge is Q by 2 plus Q by 2, because the C having the charge Q by 2 and the charge on the B is Q, so that Q by 2 plus Q by 2, that is 3Q by 2 by 2, that is 3Q by 4. So finally the charge on the C is 3Q by 4. Okay students, here you see the charge on the A is Q by 2 because it is contacted with C initially, and later it is contacted with B. The charge on the B is also 3Q by 4. So if you see, the charge on the B will be 3Q by 4 because having the equal charge is located on the C and B while making contact with B. And what is the force acting? Finally, we are going to calculate the force experienced by the sphere C will be. So what is the force experienced by the C? So C repels A and C repels B. So suppose the C repels A with a force F1 and C repels B with a force F2. So if you calculate F1 and F2, the resultant of these two forces gives the final value. So that initially what is F1 here? F1 is a force acting between A and C. So A charge is q by 2, C charge is 3q by 4, and K into q by 2 into 3q by 4 by the distance is r by 2 whole square. This is F1. Okay, the force acting between these two spheres. And next F2 is equal to, that is the force acting between C and B. So here K into 3q by 4 into 3q by 4, because while C is making in contact with B, the B charge is also 3q by 4 like C. So that F2 is equal to K into 3q by 4 3q by 4 by r by 2 whole square. So what is the resultant force, F1 and F2? The resultant force we are going to calculate here. So FR is equal to F2 minus F1. See, F2 minus, here F2 is equal to, take common factors, K by r by 2 whole square, that is common in the both, and 3q by 4 also common, and here q by 2 minus 3q by 4 minus q by 2. Okay, F2 minus F1. Here F2 is 3q by 4 and here the factor is q by 2. If you take it, the common factors, finally K into r by 2 whole square, that is 4k by r square into 3q by 4 into 3q by 4 minus q by 2, that is 3q minus 2q by 4. Finally the resultant force acting on the C is 4k by r square into 3q by 4 into 3q minus 2q, that is q by 4. So finally 4 and 4 both are cancelled here, and K into 3q square by 4r square. So this is the resultant force acting on the C with respect to the other two spheres. So already we know K into q square by r square is F. So that this is 3F by 4. So in terms of F, we calculated the final resultant force acting on the C. Okay students, here initially the problem is the two charged spheres are given. One is A and another one is B having the same charge, and another uncharged sphere C is given. So initially C is making contact with A and C both having the similar charge q by 2, and after that C contact with B. So on B and C having equal charge 3q by 4, and finally we place the C in between A and B. What is the force acting on the C with respect to A and B, or the force acted by the C on the A and B? So force acting on the C, we calculated the resultant of F1 and F2. Finally the resultant FC is equal to 3F by 4. Okay, let us go to the next problem. Okay students, let us see the problem. A 1 meter long wire, see 1 meter long wire, this is 1 meter long wire, is broken into two unequal parts. 1 meter long wire is broken into two unequal parts. Let us suppose this is first part and this is second part, and these two parts are X and Y. So two unequal parts, first part is X, another part is Y, and let us suppose the part of X is Lx, the part of Y length is Ly. Okay, next see, and the X part of the wire is stretched into another wire W. Here the X part of wire is stretched into another wire W. Let us suppose the X part is stretched into the another wire W. This is W wire. and length of W is twice the length of X. Here the length of X we consider as Lx. So the length of W is twice the length of X. This is W part of wire. W is the wire formed due to the elongation of the X, right? But the length is twice the initial value. Here Lx is the length of X, so W is 2Lx. And next, and the resistance of W is twice that of Y. Let us suppose the resistance of W is Rw, which is equal to 2 into resistance of Y. Then find the ratio of lengths of X and Y. The question is, what is Lx and Ly? What is the ratio between these two lengths? Okay, so here 1 meter length of wire is given, and which makes into two parts. That is, one part is here we consider that is X, and another part is given Y, and the total length of the wire is 1 meter. And the W is when X is elongated, then it will be turned like W. The length of the W is 2Lx. So that and one more another point is given, resistance of W is 2 into resistance of Y. Resistance of Y is Ry and resistance of W is Rw here. Then what is the ratio between Lx and Ly? And if you want to calculate the ratio between Lx and Ly, you need to calculate the resistance ratio Rx by Ry, because Rx by Ry is equal to Lx by Ly. Rx by Ry is equal to Lx by Ly, because R is equal to rho L by A. We know the relation R is equal to rho L by A. Rho is the specific resistance of the material, L is the length of the body, and A is area of cross section. So that the remaining factors are constant, we take it Rx by Ry is equal to Lx by Ly. So if you want to calculate Lx by Ly, in place of that if you calculate Rx by Ry, that is enough. So our aim is to calculate Rx by Ry, which is equal to Lx by Ly. So what is Rx? Rx by Ry, because we know the relation Rw and Ry, but we don't know the relation between Rw and Rx. So we need to calculate the relation between Rw and Rx. And one relation is given here. See, another wire W, length of W is twice the length of X. That is the main point here we used to calculate the resistance of X. Because the resistance is rho L by A. So if you stretch the wire, one factor is constant, that is volume. So if you multiply the relation with L and divide with L, then it is, which is equal to rho L square by V. Then R proportionality to L square in that case. So if X is elongated and it will be turned like W, but in that case the resistance, how the resistance will be changed? R proportional to L square. So that Rx by Rw is equal to Lx by Lw whole square. So see, Lx, this is Lx, but Lw is 2Lx. That is also point given in the problem. So that Lx by 2Lx whole square, so which is equal to 1 by 4. So students, if you see, Rw is equal to 4Rx. So by using the given relations, we calculate Rw, resistance of the W wire, which is equal to 4 times the resistance of X. So already we know resistance of W is 2Ry, which is given in the problem. So based on these 2 points, because Rw is equal to 2Ry, Rw is equal to 4Rx. So finally 2Ry is equal to 4Rx, and Rx by Ry is equal to 2 by 4, that is equal to 1 by 2. So students, the answer is 1 by 2. Rx by Ry is nothing but Lx by Ly. Okay, the answer is 1 by 2. Okay students, let us see the next problem. A tube of length 50 centimeters is filled completely with an incompressible liquid of mass 250 grams and closed at both ends. The tube is then rotated in horizontal plane about one of its ends with uniform angular velocity x root f, then what is x? That is the question. Here you see a tube is filled with a liquid. Let us suppose this is the tube filled with a liquid having length 50 centimeters is given 50 centimeters, and the tube is filled with a liquid. Okay, and see the next it is rotated in a horizontal plane. The tube is rotated in this way with an angular velocity omega. Then force exerted by the liquid on the other end, because when it is rotated, then liquid will exert force on the other end, so that like a centrifugal force. If washing machine is rotating, the water will stuck to the ends of the wall. In the similar way, here the centrifugal force act by the liquid on the other side of the wall. So this centrifugal force, we know the relation for centrifugal force, that is m omega square r. R is the distance, omega is the angular speed, and m is the mass. Here it is a continuous mass distribution, so that we take a small part here, that is dx. This is part dx, which is at a distance x from the rotating axis. So the distance x, the small part having the mass dm. So dm is the mass of the small part. So then what is dm? Mass per total mass is, let us suppose m is the total mass per unit length into dx, because the mass of the dx part is dm. Mass of the dx part is how much? Mass per unit length. Because of this is uniform mass distribution inside the liquid, mass per unit length is m by l. So m by l into dx is nothing but dm. Okay, so initially the force acting with respect to the small part on the other wall is equal to dm is equal to df is equal to dm into omega square into x. That is the force acting on the other side with respect to the small part. With respect to the small part, we calculated initially, and let us integrate to the total part, integrate to the limits, so that by integrating on the both sides, integral of df is equal to integral of dm omega square x. Integral of df is nothing but x, and integral of dm is m by l into omega square x dx. Okay, so here the length is 0 to l, total length is l. So finally f is equal to m by l omega square are constant factors. We will take it out of the integration, and integral of 0 to l x dx. So m by l into omega square into x square by dx, x square by 2 integral of x dx, which is equal to 0 to l limits. And finally substitute the value of l here, l square by 2. So m omega square l square by 2, and here l cancelled, so m omega square l by 2. This is f. So f is equal to m omega square l by 2. So the value of x, here the angular velocity is given x root f. So we calculate the angular velocity in terms of f to identify the value of x. So angular velocity here is omega square. So that implies omega square is equal to 2f by m into l. So omega square is equal to, omega is equal to root 2 by ml into root f. Okay, so what is the mass? M is given here, length filled completely with a mass 250 grams. So in place of mass m, substitute 250 grams. See, 2 by 250 grams, 250 into 10 power minus 3 into length. Length is given 50 centimeters, that is 50 into 10 power minus 2 into root f. So 250 into 10 power minus 3 is nothing but 0.25, and this is 0.5. 0.25 is 1 by 4, this is 1 by 2. If you take it into the numerator, which is equal to root 16 into root f, so which is equal to 4 root f. Okay students, I hope you got the answer finally. 4 root f means what is the x value? X value is nothing but 4. If you compare the final relation with the problem, the value of angular velocity is x times the root f. We calculated that is 4 root f, so the value of x is equal to 4. Okay students, so this is very easy to do, but a little integration, if you do it, then it is not a difficult problem. Okay students, this is the class today, and we will meet in the next class, and keep following because the examination is very near to you. Whatever the models you learn right now is very useful to you to perform your examination better. Okay, thank you for watching.